Standard 11 Chemistry Unit 4 Chemical Bondings and Molecular Structure Part 14 Type of Overlapping and Nature of Covalent Bond. We have already discussed about the overlapping of orbital. Here if 2s orbital is overlapping, in this portion is called partial interpenetration. If here if p orbital and sign is positive and the negative sign, the another p orbital is overlap. If here the same sign, the bond will be formed. Bond is formed. But here suppose here if opposite sign is here, if 2p orbital is overlap, but in this case the opposite sign, there is no bond formation. Okay, so this is the concept about the overlapping of orbitals. And now the covalent bond, as we have already discussed about how the covalent bond is formed. Covalent bond is formed by sharing of electron, by sharing of electron. Here the depending upon the overlapping orbitals, depending upon the overlapping of orbitals, covalent bond is divided into two parts. Number one, that is sigma, and number two, that is pi bond. Okay, depending upon overlapping the orbitals, covalent bonds are divided into two categories or two parts. Number one is sigma bond. This is the sign of sigma bond. And number two, that is pi bond. Okay, now let us see about sigma bond. Here it is, this sigma bond is categorized into three parts. Number one is SS overlapping, means here SS orbitals are overlapping. Number two, SP overlapping, and the third is P dash P orbital overlapping. Here in this case is in sigma bond, end to end overlapping, means suppose here this p orbital and another p orbital, this end is positive and this end is negative. Here the two end this end is positive and this end is negative. So here it is called end to end overlapping. Okay, so the sigma bond is formed by end to end overlapping of bonding orbital along the internuclear axis. First of all, SS overlapping. Here S orbital and its shape is spherical shape is S orbital, and the second S orbital is overlap each other. Some part is overlap here. It is SS overlap. This is overlapping. Here the end to end, this end and this end will be overlapping. Okay, so overlap of two half filled S orbital. Now what is mean by two half filled? That means here in the orbital there is single electron, and always the unpaired, the orbital which having unpaired electron, they are taking participate into the bonding. For example, here in hydrogen molecule, suppose two atom of the hydrogen and its electronic configuration is 1s1. So here in s orbital there is single electron. So here the one s orbital are overlapped two half filled orbitals. Okay, they are overlapping of two half filled s orbitals along internuclear axis. Now the second is sp overlapping. S orbital which having spherical shape and the another p orbital having dumbbell shape, the overlap here. So it is called sp overlap. So this overlap occurs between half filled s orbital and half filled p orbitals. The overlap occurs between half filled s orbital of one atom and the half filled p orbital of another atom. Now the third overlapping is p dash p overlapping p orbital, and its shape is dumbbell shape. Another p orbital, the p orbital, this sign plus and negative sign, they overlap each other. Here in this case, two half filled p orbitals pp overlapping. Here the overlap between half filled p orbitals of two approaching atoms. Now the concept about the sigma bond. Here the bond formed by sharing of electron, and this bond is very strong bond. Here the between two atoms, between two atoms always sigma bond exists. Sigma bond exists. For example, here suppose in hydrogen molecule, hydrogen having unpaired electron, this shares one electron. This bond is covalent bond. Or in chlorine molecule, chlorine atom which having its atomic number is 17, electronic configuration is neon 3s2 3p5. Here in 3s orbital the paired electron, and the 3p orbital it is px, py and pz orbital 1 2 3 4 and 5. So here in pz orbital, pz here its shape is dumbbell shape. Okay, and the another chlorine atom which having its electronic configuration is also neon 3s2 3p5. 1 2 3 4 and 5. So these half filled orbital, okay, pz orbital, and always overlapping of the half-filled orbitals. In this case, end-to-end overlapping occurs. Here is pz orbital and another pz orbital overlap to each other. Okay, and by overlapping of these two half-filled orbital, here means this shares the electron. Chlorine which having one unpaired electron, and this shares electron means here the orbitals are overlap to each other, and by sharing of this electron makes sigma bond. So here between two chlorine atom is covalent bond sigma type. Okay, sigma bond. Okay, the covalent bond, but which type? Sigma type. The sigma bond is formed between two chlorine atom, or here between two hydrogen atom, covalent bond is sigma bond. Okay, so between two atoms always sigma bond exists, and the sigma bond is more stronger bond. Now second is pi bond. First of all, here is p orbital and the another p orbital is overlapping of p orbital is side by side, side by side overlapping. In this case, the atomic orbital overlap in such way that their axis remains remains parallel to each other and perpendicular to internuclear axis. Yes, this kind of overlapping side by side. Here, for example, in oxygen molecule, its atomic number is 8. Its electronic configuration 1s2, 2s2 and 2p4. In 2s orbital, here the two electrons. In 2p4, 1 2 3 and 4. This px, py and pz orbital. It is 2s orbital. Second oxygen atom, which is same kind of electronic configuration. In 2s orbital there are 2 electrons. In 2px, 2px, 2py and 2pz orbital. This completely filled, and this so py and pz are half filled orbital. Px and py are half filled orbital. So here in this case py and py orbital are overlapping to each other, and the pz and pz orbitals are overlapping to each other. Okay, so here in this case the one first bond is formed, that is sigma bond, while another double bond another bond is formed, it is pi bond. Always the first sigma bond is formed. First here the first sigma bond is formed, and then pi bond is formed, and they are weak. The pi bond is weak, then sigma bond. The sigma bond is much stronger than pi bond. Let's see another example. In nitrogen molecule, nitrogen atom, its atomic number is 1s2, 2s2 and 2p3. In ps, in 2p orbital, px, py and pz orbital 1, 2 and 3. 3 unpaired electron, and in 2s orbital paired electron. Same case is here in nitrogen atom, 1s2, 2s2 and 2p3. Here 1, 2 and 3, px, py and pz. So always the orbital which having unpaired electron, they are overlap to each other. Here in this case, in 2 nitrogen atom there are 3 bond. First is always sigma bond, and now these 2 bonds is pi bond. So in this nitrogen molecule there is 1 sigma bond and 2 pi bond is formed. So sometimes you will be asked in the examination, how many sigma bond and the pi bonds are present in a particular manner, particular molecule. In oxygen molecule, there is double bond between 2 oxygen atoms. So one is sigma and second is pi. One sigma, one pi bond. So one thing is keep in mind, whenever the single bond is formed, only single bond, there is sigma bond, one sigma bond. If double bond is present between two atoms, one is sigma plus one pi bond, sigma and one pi bond. If there is triple bond between two atoms, this one sigma and two pi bond. Okay, one sigma plus two pi bond. Of for example, here suppose in methane molecule, carbon and it has 4 unpaired electron, and the hydrogen which has 1 unpaired electron, and so there they shares one electron. So here in this case it shares one electron and the single bond is formed, and this single bond is sigma bond. So 1 2 3 and 4 sigma bond is formed. There is no double bond, and that's why 0 pi bond. Okay, suppose here is CH2 double bond, CH2 double bond CH2. Here in this case between two carbon atom there is double bond, and here the hydrogen atom, two hydrogen atom which is bonded with the chlorine atom. So here between carbon and hydrogen is 1 2 3 and 4 sigma bond, and second is, so here between carbon and hydrogen 4 sigma bond, and here between carbon and carbon atom 1 is also sigma bond, and here the pi bond. So 1 sigma, and here the 1 carbon double bond carbon is 1 pi bond. So total bond formation are 6 bond, 4 sigma plus 1 sigma between carbon and carbon. So here total 5 sigma bond and 1 pi bond is formed. Okay, is called ethene molecule. Now suppose here in ethyne molecule, between two carbon atom there is triple bond. Let's see, simplify here, and the carbon and hydrogen in single bond. So here the simply whenever the single bond, this here 1 and 2. In triple bond always 1 sigma single bond and 2 pi bond. So in this case 1 2 and 3 sigma bond and 2 pi bond. Okay, so this is the concept about the sigma bond and pi bond. Next time we will discuss another topic. Thank you very much.